Hello, everybody. Nice to see all of you. So today we're going to talk about Data SecOps with Unity Catalog, how to kind of achieve high leverage governance at scale. So quick introductions to ourselves. I'm Zeashan Pappa. I'm a product lead on the data governance side for Databricks. And
yeah, I'm Deepak. I'm a senior solution architect at Databricks, based out of Australia. So I've been with Databricks for almost 3 years now. And I have 12 plus years of experience helping customers build data and AI solutions across APAC. Thanks, Zeashan.
Yeah. So I'll start with a kind of overview, as I see it, into what I think Data SecOps is. So I'm sure that some of you are going to come to me after this talk and are going to disagree with me and tell me, well, you forgot about this and you forgot about that. But at a really super high-level, basic level, Data SecOps are frameworks or automation methods that basically give you the ability to manage data and users. So if you think about that, it's kind of like data ops, it's kind of like DevOps, it's kind of like SecOps, but it kind of spans across all of that. And it's basically frameworks or methods that give you the ability to govern data and users in ways that are high leverage. And when I say high leverage, if you think about leverage, what that means is I want to do a little action and get a lot out of it, right? I don't want to be able to waste my time doing things in a super granular way or across the entirety of my organization or data estate because it's just not, it's not feasible, right? And as such, this is obviously primarily driven through automation. So if we think about like an example flow of what Data SecOps would look like, right? A user might make some kind of access request to, say, for example, a ticketing system that would be picked up by somebody like a steward or a data owner that decides, hey, I'm going to approve your access to this. And then through some process, right, that approval actually either gets done by an individual or by a team or by some automation process by which that user is then granted access to that data and then able to actually go and access it through their data platform, right? So that's kind of the overall super high level, zoomed out to a 5 miles high in the sky flow of what this looks like. So before we get too further, I'm sure all of you know what Unity Catalog is, but I'm going to dive into some of the fundamentals regardless, so we can kind of level set for all the people in the room and talk about how we're talking about Unity Catalog today, because obviously this is Databricks and we constantly evolving and changing our products. So for those of you that are unfamiliar with Unity Catalog, it is unified governance for data, analytics, and AI on the lakehouse in the Databricks platform. It gives you the ability to have unified visibility into your data and your AI assets. It gives you a simplified single permission model across data and AI assets. It gives you AI-powered observability into your jobs, into your data itself. It also opens the path for data sharing powered by Delta sharing. So it's pretty cool stuff. From a core fundamental feature perspective, we have things like access controls, ensuring who can access what piece of data or see what segment or subsegment of data. We have a lineage product within Unity Catalog that gives the ability to see where data is coming from, how data is being used. We also have discovery features allowing you to do things like, for example, tag data and ensure that I can kind of create a simplified business taxonomy for my users so they can search for something like sales information and see all the tables that correspond to information about sales. I also have the ability to monitor all of this, including things like billing data, for example. I want to see how my charge consumptions are changing, what users are kind of expending the most amount of money, so on and so forth. So all this is available, as well as auditing, understanding who has access to what data, and also who has access to what data, and who's actually accessed it, run whatever specific queries that they've run. We have all this available inside metadata system tables as well as audit tables within Unity Catalog. And lastly, the sharing bit, which powers basically our marketplace product as well as our cleanroom product, giving you kind of differential privacy between different collaborators. But all of this, all these really cool features are all kind of powered by having a single metadata layer, right? And that single metadata layer is Unity Catalog. So just a quick overview. Some of you are in the journey of working through what Unity Catalog may mean for your organization. I'm going to give you kind of a very brief level overview. I have a colleague tomorrow in a deep dive session. I think I want to say it's 11:30. We're going to go into this in greater detail. But in short, Databricks and Databricks accounts and kind of how they relate to your cloud provider is different, of course, for each cloud provider because each cloud provider is different. So in Azure, as an example, you have an AAD tenant, and that tenant is the entirety of your organization in most cases, and you'll have one account, one-to-one, that's tied to that tenant. Inside that account, that Databricks account, you'll have many different workspaces, but those workspaces are tied to different Azure subscriptions, and you probably have a multitude of these if you're a large organization. You might have one for each business unit, one for each group, team, so on and so forth. However, the management of the account and the metastore and all the assets that are Unity Catalog is done at that tenant level. And it's not dissimilar as we go across clouds. Within AWS, you've got obviously an organizational unit, which is similar to a tenant concept, and you've got these different accounts by which you bill in AWS. Databricks accounts are paired to the AWS accounts, and the AWS accounts contain those workspaces. Similarly, in GCP, you've got marketplace accounts, which have entitlements and projects underneath them, and Databricks workspaces are tied there. However, the Databricks account is, again, tied to the marketplace account. So there's some commonality here, right? It's a central governance platform. It's aligned centrally and fits centrally across the collaborative or the corresponding cloud abstractions that we work with. All right, so I want to talk about a little bit about fundamental concepts, and then I'm going to build these fundamental concepts, and then Deepak is going to kind of expand on them as we talk about how to leverage these in scalable ways. So when we talk about the fundamental concepts, we've got a few different ways of working with file-based data sources, the first of which is called a credential object. This is nothing more than an abstraction on top of a cloud security abstraction. For example, a managed identity in Azure, an IAM role in AWS, a service account in GCP. All of these basically give Unity Catalog a way to be able to access storage so that we can, kind of sign URLs for compute or, like clusters or warehouses to be able to actually go and read data. Those credentials are used to create objects called external locations, and this is just a storage location. It could be an ABFSS path in ADLS. It could be an S3 path in AWS. It could be a GCS path in Google. And ultimately, you can use this to store things like external tables, external volumes, arbitrary files, or use it as a default managed location for a catalog or a schema. And that basically gives us the ability to create things like managed and external tables. There's some differences in what managed versus external means. I'll dive into this significantly more tomorrow. But in short, it's similar to how this worked in Hive. And we also have recently introduced a concept which I'll build on in a minute called managed and external volumes. These are effectively arbitrary file containers that live inside a managed or external location. And this is all on the left-hand side in terms of working with file-based data sources. Now, with working with databases, we have things like connection objects and foreign catalogs. A connection is exactly what you think it is. It is an abstraction that allows you to encapsulate a credential and connection information to be able to connect to an external or foreign database. And a foreign catalog is that catalog that represents that foreign database inside Unity Catalog. So, for example, I want to connect Snowflake or MySQL or Oracle or whatever it would be. I can do that via a foreign catalog. All of this, I'm very proud of this slide, hopefully you like it. This is amazing to me because working with, and in this industry for so long, being able to have a single governed namespace across file assets, across database assets, to me is simply magical. I can access my legacy metastore so that your Hive metastore that existed in every workspace prior to Unity Catalog is available via a convention-based name, Hive_metastore. So you can still access all the data that's in there. You can still access any data that's inside Unity Catalog, that's formally registered inside Unity Catalog, as you can see on the right-hand side. You can access foreign catalogs that live in different systems, and you can kind of put it all together and run it, put it all in one query and run it and do it at speed with Databricks and the Databricks platform. So it's pretty amazing stuff that we've put together here. So diving a little bit deeper on managed data sources and external locations, I briefly touched on what a managed table is versus an external table. A managed table is basically a table that exists, or when you create it, you do not specify a location path with that table. So for example, I create table, some list of columns, colon, right? I'm done, right? That's it. In the case of an external table, that is a table that was created with a particular location qualifier that said, hey, this table is supposed to live here. Both of these are obviously possible in Unity Catalog, but they work in different ways. So by default, when you create a managed data source is by default attached to a metastore. And you can have and will have, I think we have in the next slide, different scopes of where managed data sources can live. So for example, you can have a managed data source on a catalog or on a schema. And depending on where you create that, logically within the namespace hierarchy of Unity Catalog will dictate where that data is stored. For external tables, again, you're providing a qualifier in terms of where that data is accessed. And then obviously things like arbitrary files and cloud storage, those live directly inside your container buckets, and they're registered with something that I'm going to talk about in a moment called volumes. So as I was mentioning in the previous slide, when you think about using managed data sources, and you should use managed data sources because we have a lot of really cool optimizations that are coming with managed data sources, specifically things like speed enhancements, cold read, metadata lookups, things like that. So there's some awesome stuff coming. We want to make managed data sources and managed tables the way to go in the future. But thinking about those and how do you use them, right? You have different ways in which you can kind of default how things are stored. So as I mentioned before, store it at the metastore, store it at the catalog, or store it at the schema. So depending on where you might have a managed data source associated with a schema or a catalog or the metastore by default, you can dictate where things are stored. This is really useful because, for example, you might have a group that you want to give access to Unity Catalog in. You create them a catalog, you give them a default storage bucket, you don't give them access to an external location, and guess what? You've given them one place in which they can store data. So you can start to make some pretty cool guarantees about how your users and your groups of users are interacting with Unity and interacting with Databricks. So one of the things that's interesting and important to understand about Unity is that you have multiple ACL trees. So even if you register a table, say an external table, inside an external location, the ACL tree that governs that particular table is different than the ACL tree that governs the external location. So for example, I might have read access to a external location, write access to the external location in this example, but I only have select on a table that's registered in that particular external location. That means that even if I try to read it by a path via the table name, I won't be able to read it even though the parent container, I have access to it. So this is cool to note, right? Like tables are kind of, safe entities like within Unity Catalog, and once you register them, they have their own ACL trees. You're able to govern them somewhat independently. All right, so the last bit I'm going to close on is volumes in Unity Catalog. So this is, to me, awesome and a huge leap forward. Basically, the idea here is that you can access, store, and process any kind of file with Unity Catalog governance. So a volume is an object that sort of lives beneath an external location. So if you look at the diagram on the right, I've got this little box that says volume. It lives underneath an external location, and inside that volume is some arbitrary data. Just to be clear, this is non-tabular data in general, or data that I'm not going to register with my catalog. Right? So I might create a table that lives in a file, and I'm not registering with the catalog. Maybe it's some output from a job I'm working on, or some test data that I'm kind of operating with. And this is exactly what volumes are used for. That's also used for things like unstructured data, things like audio files, video files, PDF, anything you're going to use for ML, right? Or even semi-structured data, as I mentioned before, that I haven't made the decision to kind of register with my catalog just yet. This includes other things like library or configuration files, operational data, other raw data files. And the coolest part, which I probably should have led with, is that you can access this via a POSIX command. So specifically, for those of you that remember working with mount files, mounts in Databricks before, mounts were really cool because I had a fuse driver. I was able to use that fuse driver to mount a cloud storage file system and then access it via shell commands inside notebook cells. Or if you're using some esoteric machine learning library that had to have physical path access, then you had to do some magic of kind of lifting your data off of S3 or ADLS and bringing it to your local node and doing some magic on it. None of that is necessary anymore. You can interact with it directly via POSIX commands and, of course, via DB utils as you were able to before. So pretty cool stuff. I will close at that on the Unity front. And we're going to move over to what Unity Catalog and Data SecOps means.
Thanks, Zeashan. So I hope we all agree Unity is great, right? I mean, what better solution to have a one-stop shop to govern both structured and unstructured data, and also with volume support, which also helps you access your unstructured data as well. So at the start, Zeashan kind of showed you an example Data SecOps flow, right? It's all about getting access to your data and getting access to an environment to play with your data. But how do you do this in a governed way is all Data SecOps about, right, at scale. So we're going to see how we do that with Unity. But before that, I actually asked ChatGPT. I was curious. I asked it to crack a joke about an organization having bad data, a bad catalog and governance. And even ChatGPT did not find that funny, right? It was like, there's no humor found there, right? You better have that. It's a serious problem to solve, right? Before I move on to the technical solution, does anyone know what this is? What this image is about? If you know, TLDR, thanks for coming, you're good to go. Anyway, I'll just leave it to the end, and come back to this. I like analogies, so I'll play with it. I'll come back to this in the end. So let's take an example, right? The SecOps example. Let's say you have multiple workspaces in your organization where data is actually spread across before Unity. This is the state before Unity, right? You have a metastore that is available for each of those workspaces, or you have an external metastore, and you have multiple workspaces that your organizations are using. And then you have some scenarios where some users, part of your business units, are asking, hey, I want access to XYZ data, and I need to do some analysis. Or there could be another type of request where from another business unit, the users may ask, I want access to this data, but I also want a compute environment to play with because I don't have one, right? So these are requirements or requests that you'll get in your day-to-day life in organizations, right? So how do you do this now? Let's say if you don't have centralized data governance here, how do you do this? Do you give them access to a specific workspace? Or do you extract the data out and create another compute environment? How do you do it? Right? It's a hard problem to solve. So what are the key requirements for us to cater for such requirements? What are the key things required, right? First thing is to centralize your data, right? No, non-negotiable, all your data has to be centralized. The more distributed your data is, the more complicated your governance problem is going to be, right? And then the second one is you need to have process to create and apply permissions at scale. So this is all about democratizing your data with governance, right? And you can't do this manually. Imagine, you have tens of business units populating data in your data estate. You can't do this, manually, just going and giving access based on requests. That's not scalable at all. You need to have a process that can be automated and scaled. And then experimentation and analysis. So this is BAU, where your business units or your users want to not just have access to the data, but they also want to have similar compute environments to actually play with it and then gather some insights out of the data. And the fourth requirement is chargeback and audit, right? So organizations do have different structures. They do have a central data team which actually, cops all the charges. Or there are organizations who have back charge mechanisms where they charge the BUs back. They even have the clouds structured, based on BUs, so they can actually back charge. So you need to have, the mechanisms to actually audit and back charge as well. And finally, destroy and roll back permissions, which is, let's say if the analysis phase is completed, you just have to revoke your data access, you just have to destroy the compute that was provisioned, and then eventually back charge. So this is a life cycle, right from requesting access to a data and compute, and how do you actually provision it, and how do you eventually clean it up, right? It's an end-to-end process, and as I said, this cannot be done manually. If you try to do this manually, you'll be able to cater for one business unit, but you can't scale, right? So moving on, I hope this works. It's not working.
No, there we go.
Let's try again. Slideshow. There you go. Apologies.
Like any good presentation, technical difficulties.
I'm going to the next slide. Just give me a sec. I hope this does now. All right. So we heard about Unity, right? Zeashan kind of walked you through the concepts of Unity, the fundamental concepts of Unity. So Unity is the first step, right? Now, when you centralize all your data from all the workspaces with Unity, you check the first box, the first requirement, where centralization is made easy, right? And moving to Unity from your existing workspace setup is not a big leap, right? It can be done. You can just turn that switch on. But we are just halfway through. There still are more requirements for us to cater for, because centralizing the data alone is not going to be enough for us to do data SecOps at scale. So what do we need for that, right? Terraform, right? So who's familiar about Terraform here? Pretty much more should be, right? So this is not a Terraform course. I want to call that out. I'm just going to give you some fundamental concepts about Terraform, but I would like to walk you through as to how you can apply this to do data SecOps at scale. So Terraform is technically an infrastructure as a code tool to actually automate your infrastructure and your service deployments, right? And it is managed by HashiCorp, and it's an easy-to-use declarative type of coding where you just tell what to do and forget about the how, right? You just code it declaratively. And one of the key benefits of Terraform is it's multi-cloud compatible as well, right? So you can just have similar concepts apply to one cloud today, pretty much take and apply to another cloud later by just tweaking it a bit, right? And it's also provider-based, and it has multiple providers as well, and Databricks is one of the Terraform providers. So just real quick intro about the Terraform terminologies. So we have what we call as providers, and providers are nothing but plugins to interact with the APIs. So you can actually call the APIs via the providers. And then resources are infrastructure templates where you have all your configurations kind of mapped. Resources are infrastructure objects that you actually use to create those resources, be it in the cloud, or it could be the Databricks resources as well. And module is a Terraform template where you have all your configurations defined. And then finally, you have variables, which are nothing but your key value pairs, which you actually use to customize your Terraform templates and then make it a bit more modular. And finally, Terraform has a state, which actually maintains the state of the infrastructure in its current state. Right? These are some key terminologies that you would come across when you're using Terraform. So Databricks is a Terraform provider, right? And on top of giving the capability to spin up Databricks workspaces, we also give you capabilities to deal with Unity Catalog as well. So whatever you see in the bottom half of the screen, where you see Databricks grants, metastore, metastore access, external location, these are all Unity Catalog resources, right? So whilst you can do this online via the UI, just from an experimentation perspective, if you want to do this at scale, it's much better to do this via automation tools like Terraform. All right, so I'm going to walk you through an example as to 3 steps, on a very high level, what would you do via Terraform to actually create a workspace and Unity Catalog. This is not going to go into the details. It just talks about very high level stuff here, right? So if you look at this, and this is the AWS version, probably will be pretty similar for the other clouds as well. So here, our goal is to create a workspace, right? So what would you do if you want to do this via Terraform is you will play with 2 providers here, which is the AWS provider and then the Databricks provider. And then all you need for the workspace to be created are 2 resources, which are storage configuration and credentials, right? So storage configuration is nothing but a root S3 bucket that is actually required for the workspace. So you create that resource in AWS, which is an S3 bucket with a bucket policy. And then you also need a cross-account role, which is an IAM role, and you create a policy in IAM in AWS and map it to a credential. So once you map it to these 2 resources, storage configuration and credential, you use that to actually create a workspace, right? So likewise, how do you create a metastore, right? So for you to create a metastore via Terraform, you need 2 resources, which are metastore and metastore data access, right? So a metastore is nothing but an S3 bucket, or in other clouds, it could be the equivalent object store, ADLS or GCS. And then for Unity to interact with that metastore, it needs a credential as well. And that is the metastore data access, which is nothing but an IAM role, right? So these are the 2 key resources that you will need with which you can actually assign metastores to workspaces. So once you do that, you can now play with all the other resources that are available to interact with Unity Catalog via Terraform. And those are examples such as catalog, schema, external locations, storage credentials, SQL table, grants, and we will have more as well as when we release more features into Unity. So that's a brief intro to Terraform and how do you use that on a very high level to create workspaces and metastores and play with it, right? So let's put this together. So Unity Catalog solves your unification and your data consolidation problem. So you consolidate all your structured and unstructured data in one place across all your workspaces. And now, when you embed Terraform with some kind of a job runner, along with it, which can actually kick off your Terraform pipelines, you're almost there because you check. Now you have a process to create and apply permissions at scale via Terraform. You can create compute environments with Terraform, right? You can create more ephemeral workspaces, based on requests, and you can also destroy and roll back via Terraform as well, right? So if I have to, again, give you an example, imagine the example that I showed you before. If I'm a user from a business unit, if I want access to a specific data, read access for like 5 days, I can raise a request to ITSM via a ticketing process, and that will then go to your Data SecOps owner, and that Data SecOps owner, based on approval, will trigger a job which will kick off Terraform, and that will create Databricks workspaces. It will also provision access to data, and then it will hand it over to the user, so the ticket is actually solved, the ticket request, and the user then plays with the data in that compute environment for whatever duration that was provided. That duration could be hours, that duration could be days, or it could be a permanent workspace as well, right? So the only missing piece in the puzzle here now is chargebacks and audits, right? So how do you do that?
Before we get there,
Yeah.
one thing to keep in mind, your flow, your process may not look like this. That's okay. You may have a user, you may have a more perhaps open environment. Your users might be doing or submitting the code Terraform changes themselves and somebody's approving them. There's no wrong way to do this, right? There's the right way, and that is the way that your organization deals with data. This is a way to basically make the whole process of provisioning your environment, provisioning access to data, ensuring that the right people have the right access, to Deepak's point from earlier, democratizing that usage. This is a super easy way to get started, and it's a really, really great pattern for organizations that want to do more with less.
Thanks, Zeashan. So he didn't tell us about chargeback and audit, so I think the answer is, there you go, it's on you. Anyway, so how do we solve the final piece in the puzzle? System tables, right? So Databricks also gives you what we call system tables, which is a unified interface for delivering all your operational data, right, in the form of logs. So this is managed and delivered by Databricks. So how does it work? Is you, as customers, you use Databricks products, and you use all the features that are provided in the platform. And there are different SKUs available in the platform, right? You create an all-purpose cluster. You can create a jobs cluster. You can create workflows. You can do SQL queries, dashboards. You can do everything, right? So you, as a customer, use all the features. And what this does is this actually generates operational data. And this operational data is then managed by Databricks and processed by Databricks to actually create predefined delta tables. And those delta tables are then made available as system tables in your catalog via Delta Share, which then you can consume to actually do monitoring. Or you can use that to analyze your billing logs, right? And it's a central catalog at your account level, so it has information for all your workspaces, right? So you can actually do workspace-based analysis as well, right? So system tables are the last step in actually checking the chargeback and audit, but this will help you analyze your Databricks usage and backcharge your business units for the Databricks usage. But for you to fill the gap, you also have to analyze your infrastructure logs as well. If you want to charge them for the VMs, charge them for the networking costs, charge them for storage costs, unless you don't have separate BU structure in the account levels in cloud. Like let's say if you have one monolith account and you're only provisioning workspaces within that, you would have to analyze your infrastructure logs as well. But if you have separate organizational accounts for different BUs, that problem is simplified. So you may or may not need your infrastructure logs on top of this to actually charge back your business units. So what does systems logs look like? This is an example of the billing logs table from the system logs. So you can see here, you can actually look at your DBO consumption trend by just running a simple SQL query. You can look at all SKU level analysis as well. So if you want to understand what your jobs usage is versus your all-purpose, you can do that as well. And then if you want to do a user level analysis, you can do that. Becomes really, really handy for a manager during performance time. You're like, hey, which user is spending more money? Like, come, let's have a chat, right? And then, you can also do job level analysis as well. There are much more information other than this that are available as part of the system tables. So what I'd like to do is give you a quick demo This is a recorded demo, so I'll just play this for you.
Hi everybody, today I wanted to show you how to set up an alert on top of a Databricks system table. In this case we have a billing example here. So suppose we wanted to know if our DBU utilization exceeded a certain percentage of our monthly budget. Like if we're spending over 90% of our budget, we want an alert. How do we set that up? So first we're going to create a query and then we're going to set an alert on top of that query result, right? So we're going to add sum of DBUs over, let's say our budget was 400,000, and we're going to call that our DBU utilization. And then we're going to make sure that this is this month, right? So we're going to add a condition that just says we want this to evaluate for this month only. Awesome. So we're going to make sure we save that as well. Give it just a second. Cool. And we see that our utilization was 66% this month. So now we want to set an alert on top of that. How do we do that? So we go over here to this alerts page. We click create alert. We're going to select the query that just ran. And then we see that we can choose the column, which is DBU utils. That's the result column that we want to alert on. And we want to set the threshold in this case to 0.9, right? 90%. We're going to keep the defaults here. Refresh frequency right now is every hour. We're fine with that right now. And now we have a basic alert. So by default, it's going to send to the creator of the alert, but we can add other destinations. So we can also notify, let's say, Michael Millerud. So now he's going to be notified when this is triggered. You can also add Slack, Teams, PagerDuty destinations. You can also choose to have a generic webhook set up as well. So let's say this triggers, this is greater than 0.9. You'll get an email that's something like this. This is a different example I created earlier. In this case, I set the threshold to 0.5. And you'll see I got this email notification, and I can go to the alert and go to the query. If you go to the alert as well, you'll be able to see this was triggered and last triggered 21 minutes ago. So that's how you set up a basic Databricks alert on top of a system table.
There you go. So just a quick recap. What was done there is a billing log analysis query was actually created, and it was scheduled to send alerts based on a certain threshold. Right? So when could this come handy? Right? Imagine the same scenario that we are speaking about, where your business users are requesting access to a data and a specific compute. So you're provisioning their own ephemeral compute environment, like a Databricks workspace environment, and you're giving them access to data. And you're saying, all right, here you go. You have been allocated this budget, and you have 5 days or 10 days to use, right? But then you can schedule this SQL query to monitor that workspace's usage, and you can alert them on a daily basis, based on how much they're consuming. Let's say if the trajectory is exponential, or if they're consuming a lot, you can always have a conversation with them to understand what the requirements are and then tweak it, right? So it comes in really handy, for you to track consumption, plus doing way more, because billing logs is just one part of system tables. System tables has way more than that as well.
One of the things to add to that, one of the things you can also do is actually send it out to a webhook, right? So if you want to tie that into some system that automatically removes their access or terminates their account, you can do that, right? Don't pass our threshold, or things will happen, right? So there's teeth behind this as well, right? It's not just a way for you to monitor it with the alert system that we have inside Databricks. You can actually do things based on that.
Create an automation pipeline. To Zeashan's point, if they exceed a certain budget, you can automatically, pause their access to the environment till you figure out what's going on. So there are ways in which you can manage this. All right. So now tying this together in the Data SecOps flow that we were having a look at is, so when Unity meets Data SecOps, it's actually magic, right? You're able to now centralize your data. Now you have a process and framework to actually create and apply permissions at scale, and you're able to provision ephemeral compute environments for users to experiment and analyze data, users who want to be self-service. And now you have a mechanism to charge back an audit, and you also have an automated mechanism to destroy and roll back permissions as well. So that is possible with Unity, with Terraform, and with system logs and infrastructure logs if applicable. So I'll come back to this now, right? So this is about how perceived underdog called David won against a mighty, Goliath, right? So this is David versus Goliath, right? Again, I assume you appreciate my Photoshop skills here. So I'm going to show you something interesting in the next few clicks. So what we're trying to say here is, David was an underdog, but with his right mindset and right approach and a right tool, he was able to win against a mighty Goliath. So what we are trying to say here is, with the right tool and with the right mindset and execution, you'll be able to make this a reality in your organizations, and you can do data SecOps at scale. And that's it from us, and we have 5 minutes, so we are more than happy to take questions. Thank you.